In this video, I will talk about a concept called concentration and what means by concentration. And it is actually a measure of the amount of a solid per unit volume of the solution. And be reminded that it doesn't mean that when I dissolve a certain gram of solid in 100 ml of the solvent, then we can calculate by these two values. It's the amount of solid divided by the overall volume of the solution. Is it okay? And there are so many ways for us to represent the amount of the solid. We can represent it by gram, or more commonly in chemistry we use number of moles of a substance. It's because for different substance they have different masses, they have different molar mass. So if we say it has 1 gram of that particular substance, it cannot directly reflect the number of it. You see the idea. However, if we convert it into number of moles, then everything will be clear. And for the volume part, we usually use the term dm curve, measured in dm curve. And the meaning of D is that, say for example, 1 decimal place, it means that 0.1, it means that 1/10 is something related to 1/10. So for this dm, it means 1/10 meter, that is 10 cm. And then when we are talking about the volume, we have to use this 10 cm to the power 3, because it is a 3-dimensional world, so that we have to add the power 3, and it equals to 1000 cm cube, or you can say that E equal to 1000 mil, or if you use another unit of it, it will be equal to a liter. However, for chemistry, we will write it in this way, 1 dm cube. And as mentioned before, for the concentration we can calculate in this way. Okay, mass of a solid and then divided by the volume of a solution. So if we consider the concentration in this way, then the unit, we call it gram per dm cube. And as mentioned before, there are so many ways we can represent the amount of solid, and they can be presented in this way. Depends on what information is or are given. Is it okay? And there is a special type of concentration. We use number of moles to represent the mass of solid, and then we use dm cube to represent the volume of the solution, and that concentration is called molarity. If you refer to the equation below, the molarity equals to number of moles of a solid divided by the volume of the solution. And the unit of it, we can use two presentations. First one is mole per dm cube, and then the second one is capital letter M. And that's all for today. Actually, it's because you just need to trace the units, and then you can calculate the molarity and the concentration by these two simple equations. Let's check if you can really understand the concept. First of all, if we have 2.5 gram of NaCl, and the final volume of solution is 250 ml, and then you have to present the concentration in these 3 units, and then how to calculate them one by one. For the first one, in gram per dm cube, it means that we would like to present the mass of sodium chloride in gram, and it's just 2.5 gram as said in the question. And then how about the volume? Now we want the unit of it is in terms of dm cube. So for 250 ml, it will be equals to 0.25 dm cube. You see the idea is because 1000 ml equals to 1 dm curve, so that we have to divide by the ratio. Oh, and then finally, what you have to do is just use the mass divided by the volume of the solution in dm cube, and then we can get the answer. The concentration in gram per dm cube of NaCl. And be reminded that for every calculation question, make your description clear. And then it will be equal to 2.5 and then divided by 0.25. So you got the final answer. Can you follow the flow? Oh, and then for II, again very easy. The mass of NaCl, this time I want to express it in gram. So again just 2.5 gram. And then the second step is about the volume of solution, and obviously this time cm cube is used, so 250 cm cube. And then finally just apply the formula, the concentration in cm cube of NaCl equals to the 2.5 divided by the volume in cm cube, so it is 0.01 gram per cm cube. Oh, is it clear? Oh, and then how about the most important one in chemistry, the molarity calculation? And capital letter M is equivalent to mole per dm cube as a unit. So again, you follow the steps. First of all, it's about the mass of NaCl, is given as 2.5 gram. And what you have to do next is that we have to present the amount in terms of number of moles. So number of moles of NaCl equals to 2.5. We use the relationship mass divided by molar mass. And here is the first item, we need the number of moles. And then for the volume term, we would like to present it in dm cube. So again, starting from the 250 given, and then divide by the ratio. So again, equal to 0.25 dm cube. And finally, molarity of the solution. Just use the number of moles. And then divided by the volume in dm cube. And then after round it to 3 significant figures, you can get the answer 0.171 m, or you can write it as 0.171 mole per dm cube. And personally, I like this unit more. And can you see how can you apply those relationships? And of course, you can change the subject a little bit for this equation for you to memorize it more easily. Is that number of moles equals to mv. M means molarity and V means volume in dm cube, and it is equivalent to the number of moles of solid inside. And of course, there are so many ways to present the concentration apart from this gram per cm cube, gram per dm cube, or mole per dm cube, this molarity. Sometimes we use percentage by mass to represent the concentration. Say for example, for the alcohol we use for killing bacteria, we use for sterilizing, maybe 90 something percent or 75%. And these, again, they are the concentration. However, they are in terms of percentage. It means that in maybe 1 100 gram of that solution, then the mass of the alcohol is 90 gram. And there's this kind of presentation. And there is also another tool called ppm and ppb, and their meaning is that part per million. And part per billion, it means that in a million gram of the sample, then only 1 gram of it is the certain analyte or the certain substance, certain chemical inside. And these two units are usually used for some pollutants inside the air or the particular chemical inside some water sample and etc. You may ask, is there any quicker way to do the unit conversion from maybe gram per dm cube to gram per cm cube or even to mole per dm cube? And if you really study their unit, you can find out the relationship behind. Say for example, for the concentration, okay, in gram per dm cube, the calculation method is that we use the mass of the solid in terms of gram, we divide it by the volume in dm cube of the overall solution. Oh, and then for the molarity term, the method of calculation is that we use the number of moles of the solid divided by the volume in dm cube. So if you compare these two terms, at the bottom, for the volume term, they are just the same, isn't it? And then what's the difference is that we just need to divide the whole concentration term, okay, by the molar mass of the solids inside. Divide the whole term by molar mass. And then we can immediately turning the upper part in the concentration in gram per dm cube into number of moles of the solid. And then the whole term on the right hand side is just equivalent to molarity. So the direct conversion from concentration in gram per dm cube to molarity is that we just need to divide the whole term by the molar mass of the solid inside, and then we can get the molarity term. And if you want, you can have a try. Say for example, in question I, we already calculate the concentration of solution in gram per dm cube. And then how can you directly calculate the answer in III? Is that you need to use this 10 and then divide it by the molar mass of the solid inside, that is sodium chloride. And then you can directly get the molarity of NaCl in the solution. Can you see the idea? And then you can also apply the same thing for the conversion between gram per dm cube to gram per cm cube. It's because now the gram term, the amount of solid is now the same. However, the volume term is different. And you can see that for 1 dm is actually 1,000 times of 1 cm cube. Is it okay? So of course, in 1 cm cube of the overall solution, it contains only 1/1000 mass of the solid inside. So we just need to divide the whole term by 1000, and then we can get the concentration in gram per cm cube. Is it okay? And then the conversion from gram per dm cube to molarity is to divide it by the molar mass of the solid, and that's the quick way for you to do this kind of conversion. And then more examples on the calculation. Oh, and this time is the calculation of concentration of sulfuric acid, and then it is finally make up to 100 ml. So you have to find out the concentration of sulfate and also hydrogen ion in these three different units. So the idea is just the same. Well, first of all, it's about the mass of sulfate ion inside H2SO4, and the way is just very easy. And what we need is the percentage by mass of sulfate ion. The overall mass of it is 3.74, and then the percentage by mass is 32.1 plus 16.4, and then divide it by the overall molar mass. And this is the mass of sulfate ion inside. Oh, and then the volume in dm curve, and originally we have 100 ml, and then to convert it into 1 dm curve, just divide it by 1000. Is it okay? So finally you just need to use the mass of sulfate ion and then divide it by the volume in dm curve, and that's it. Oh, is it okay for the sulfate ion? And then if you use the relationship that I talked about before, instead of using this method, you can directly divide this term by 1000. And then you can get the answer. Oh, or if you really want to follow the traditional way, then the mass of sulfate ion inside is just the same. And then the volume in cm curve, it will become 100 cm curve. And then what you have to do is 1 divided by 2, and then you can get the same answer. Oh, and then finally, still you have two ways to do so. The first method is by using mass divided by molar mass. And then because in one sulfuric acid there is one sulfate ion inside, so that the mole ratio is 1 to 1. And then the volume in dm curve is 0.1 dm curve. So finally, the concentration in terms of molarity just equals to 3.74, the number of moles of sulfate ion, and then divided by the volume of solution in dm curve, and then you can get the answer. Is it okay? And then the same procedure is just repeat for hydrogen ion. Oh, and then finally, for the number of moles of H plus, you can have two ways or three ways to do so. And first of all, of course, you can start by the number of moles of sulfuric acid to do so. However, if you are using this method, be careful. It's because this time in one sulfuric acid, there are two hydrogen ions inside. So that the number of moles of hydrogen ion is a double. Is it okay? So the volume in DM cube is just the same, and then the molarity, we can use this way to represent it. Use a bracket, square bracket, and then H plus inside to represent the molarity of it. But of course, if you have time, write it down in as a whole, the molarity of H plus in the solution equals to the number of moles of it and then divide by the volume in DM cube, and then you can get the answer 0.762 m. And this is the first way for you to do it, starting from the number of moles divided by the volume in DM cube. However, another way is that you can start from the one above. It is because for molarity we use the number of moles divided by the volume, so that it can directly reflect the number of moles of a substance inside a certain volume of solution. So now you know that the mole ratio of sulfate ion and H plus is 1:2 ratio, so that you can see that the molarity of hydrogen ion is a double by comparing with that molarity of sulfate ion, and this is the first way. And then the second way is that you can start from the concentration in terms of gram per dm cube to do so. And this time, because the molar mass of H plus it is 1, so that you divide the concentration in gram per dm cube by its molar mass, that is equal to 1. So you can still get the answer 0.762 m. Is it clear? However, if you do the same for the conversion from gram per dm cube of sulfate ion to this molarity, you have to be careful. It's because now the molar mass of it is just 32.1 plus 16 times 4 instead of the whole molar mass of sulfuric acid. Is because you are now considering only parts of it. Oh, and the above examples is help you to get familiar with those different units of concentration. However, the most commonly asked question in the public exam is just molarity. Sometimes the HKEAA will ask you to do the unit conversion, but not as common as the calculation of molarity. Also, for question 3, just the reversed question. Originally, for question 1 and 2, you are given the mass of it and then the solution volume, and then you have to calculate the concentration of it. Now it's just the reverse. For the concentration, the molarity is given, and then the volume is given. So we can apply this equation, number of moles equals to mv. You remember this one, we just do a change in subject of it. Oh, and m means the molarity, so it's equals to 2. And then for the volume part, we remember that it should be in dm cube, so that we have to convert is 18 into dm cube by dividing it by 1000. So after you get the number of moles of NaNO3 and then what you have to do is just to multiply it by the molar mass, and then you can get the mass data. And this part is just the same as the mole calculation you handled before. And just one more relationship, number of moles equal to mv. Is it okay? And this for part A. Oh, and then part B, you can use the shortcut I gave you for the conversion of this gram per dm cube concentration into molarity. Okay, we divide it by the molar mass. And now you are given the molarity, so that you just need to multiply the molarity by the molar mass, and then you can get the answer. Here's the first way. And then the second way is that you have already calculated the mass of NaNO3 inside. So you just need to divide it by the volume of solution in dm cube, and then you can get the answer. And maybe I try the second method for you. And then finally, you just need to use the mass divided by the volume of solution, and then you got it. So is it okay? Oh, and then for question 4, a new technique, and this process we call it dilution. And the meaning of it is hazy. It means that we add the solvent into the original concentrated solution, and then to make its concentration lower. And the idea is that originally there are some solution more concentrated inside, and then there is certain number of moles of it. And then after the addition of the solvent, the number of moles of the substance inside the container, it will not change. Can you see the relationship? So we can say that in the dilution process, okay, number of moles of solids conserve. So if you apply this relationship, originally you have 0.4 m 200 ml of HCl. So we calculate the number of moles of the solid HCl first, and equals to mv, and the volume, it should be in dm cube, so the 200 divided by 1000. And then after that, because 100 ml of distilled water was added, so that the total volume of the solution, it will become 300 ml. Is it okay? So the new molarity of solution will be equal to number of moles divided by the new volume. So just 0.4 times 2 divided by 3. So 0.267 m. And this is the first way to do it. And then there is a particular equation for a dilution process. Only by dilution. If there is chemical reaction involved, we cannot use this following relationship, and this is called M1V1 equal to M2V2. And do you know the reason behind this equation? It's because for the number of moles, original number of moles will be equal to the number of moles after dilution. And we can establish these two relationships because MV we can actually calculate the number of mole before, and then MV we can calculate the number of mole after the dilution, and they are equivalent, so that we can establish this relationship. And if you study physics, it is very easy for you to memorize just the momentum m1v1 equal to m2v2. However, in chemistry now, all we use are capital letter M and V. Capital letter M is the molarity, and capital letter V is the volume in DM group. And be reminded that only when you are adding water into the solution, that means it's a dilution process, you can use this equation. In other case, you cannot apply this. Say for example, if chemical reaction occurs, you cannot use this equation, or while you are adding a solution into another solution, then you cannot apply this relationship. Only when a solvent is added to it, and most commonly water is the solvent system. Just be careful when you are using this equation. Oh, and question 5, that's what I mentioned before, is that you cannot use m1v1 equal to m2v2 in this case. Do you know why? Just study the question. Oh, now is it a dilution process? Obviously no. It's because we are now mixing two solutions instead of just adding the solvent into a solution to dilute it, so that you cannot apply m1v1 equal to m2v2. And in this case, you have to calculate the things separately. First of all, is the total number of moles of the target thing, that is the chloride ion, inside first. And then secondly, you have to calculate the total volume of solution after mixing. Oh, for the first one, is that in 1 m 15 ml of NaCl, we apply MV. And then I think you have no problem in understanding this. 1, the molarity, 50 divided by 1000, the volume in DM group. And then because in 1 NaCl there is 1 chloride ion inside, so that the mole ratio is 1. And then for zinc Cl2, the molarity is 0.244, and then times the volume in DM group. However, up to this part, be reminded that is just the number of moles of ZnCl2 only. Now what you are calculating is the number of moles of chloride ion, so you have to multiply it by 2, because in 1 ZnCl2 it has 2 chloride ion inside, and this is the mole ratio. Oh, and then for the volume is simply because you just need to add the two number, 100 plus 50, and then divide it by 1000. And finally, the molarity is just the total number of moles of chloride ion divided by the volume of solution in DM group. And that's how you can got the answer. And then there is an easier version for you to calculate it. However, don't use this relationship in DSE. And we just need to modify the above equation a little bit for m1v1 equal to m2v2. Each of the species we add a letter n before, and this N is the mole ratio of that particular substance inside the whole compound. So for example, in the above case, in ZnCl2 there are 2 chloride ions, so that will become a 2. And then for the one on the right hand side is just the final volume and the final molarity, and you can apply this. However, do not write it in DSE, but you can write it on reference sheet.